Have you ever stopped to wonder why you can remember yesterday but you can't remember tomorrow? Or why a broken egg never ever unscrambles itself? This is the mystery of the arrow of time, and it's genuinely one of the biggest unanswered questions in all of physics. Well, let's get into it, because a fascinating new framework might just offer a surprisingly clear and structured solution.
So let's just lay the core problem right out on the table. Why does time have a direction? I mean, for us, it's a one-way street, right? We move from a past that's set in stone to a future that's totally unknown. But here's the thing. When physicists look at the most fundamental laws of nature, they run into a huge, glaring contradiction.
And this is where it gets really weird. On one hand, you have the microscopic world, the equations that describe how atoms and particles behave. They work perfectly fine whether you run time forwards or backwards. But then, on the other hand, you have our world, our reality, where things are absolutely irreversible. This is the heart of the conflict. The basic rules of the universe don't seem to care about the direction of time, but our entire existence is defined by it. So, what gives?
To solve this puzzle, we might need a totally new way of looking at things. So let's explore a framework called Triune Harmonic Dynamics, or THD for short. It proposes that there's a universal pattern that governs every single change in the entire universe.
So, what exactly is THD? Well, at its heart, it's a theory that suggests every single process of transformation, everything, follows this one fundamental pattern. Now, the math behind it gets into a 3-6-9 sequence, but the easiest way to understand it is as a simple repeating three-phase cycle that's underneath everything, from how stars are born to how we form a new thought.
And this pattern is actually pretty intuitive when you break it down. It has three key phases. First, there's emergence, where a new state or a new idea is born. Then comes contrast, where you get tension and friction, opposing forces that test and refine that new state. And finally, you have integration, where all those elements combine into a new, more complex, higher level of order. And then, the whole cycle just begins again.
Now, I want to be clear, this isn't just some philosophical concept. It is grounded in mathematics. This right here is the core equation, and it was developed by researcher, inventor, and author Kevin L. Brown. It's the formula that mathematically describes that three-phase cycle of transformation we were just talking about.
Okay, so we've got this universal pattern, but how in the world does a repeating cycle solve the problem of time's one-way street? Well, according to THD, it completely recasts our entire understanding of what the past, present, and future actually are.
In this new model, time itself is one of these three-phase processes. The past isn't just gone, it's phase one. Think of it like stored potential energy, a kind of structural memory. The present, that's phase two. It's a period of building pressure and tension as information and complexity increase. And the future, that's phase three, the moment all that pressure is released into a new, stable state.
And right there, that is the crucial point. The arrow of time isn't some mysterious fourth dimension we're all traveling along. It is simply the mandatory direction of this process. It has to go in this order. You cannot have the release of pressure, the future, without first accumulating it in the present. You just can't skip the steps. Time can't go backward for the exact same reason a story can't start at the final chapter.
But for any idea to be truly scientific, it has to be testable. It needs to make real-world predictions that we can go out and either confirm or, even more importantly, prove wrong. That's called falsifiability. So let's see how the THD model holds up.
This is where it gets really exciting. THD makes some very specific, measurable predictions. For instance, it suggests that if we get things cold enough in deep vacuum experiments, we might actually see cause and effect happen in reverse, something it calls causal reversibility. It also predicts there should be tiny fluctuations in time, a kind of temporal noise that our absolute best atomic clocks might just be sensitive enough to pick up. And finally, it proposes that time can speed up or slow down, not just because of gravity, but based on the amount of change and complexity in an area, a concept it calls informational divergence. These are all things we can actually go out and test for.
And just as important as making predictions, the theory gives us its own kill switches. These are the conditions that would prove it's wrong. For instance, if we ever observe a complex system, like that broken egg, spontaneously unbreaking and putting itself back together, the theory is toast. If we find that time's arrow still marches forward, even in a place with zero informational change, the theory is wrong. And if time travel to the past is ever proven possible without a complete system-wide reset of this harmonic state, then the theory is false.
This is what makes it a real scientific framework.
So, when you put this all together, what does it really mean for how we see the universe, for how we understand time itself? Well, it suggests a pretty profound shift in our entire perspective.
The huge takeaway is this. We may have been thinking about time all wrong. It's not a line we're traveling on. It's not a river we're floating down. Instead, time is the actual pulse of reality. It's the forward-moving, three-step rhythm of the universe, constantly unfolding and transforming into its next state.
To leave you with one final thought, the theory itself puts it this way. Time is the release velocity of the universal resonator. In other words, time is basically the speed at which the universe resolves built-up tension to create the very next moment. It's not just a clock ticking away on the wall, it's the rhythm of creation itself. And that leaves us with a pretty cool question. If time is a rhythm, do you think we could ever learn to feel its beat?